Okay, dear students, engineering mechanics, problem set 2.4, solution to 2.47. Today I found few of my students are from Bangladesh. Let me congratulate and congratulations to all the viewers from India and from my neighboring country Bangladesh, right? Thank you for watching my videos. Let me proceed. If you like the contents are good, worth watching, you can give a thumbs up, or if you may like, you can subscribe and pass on to your friends as well. Solution to 2.47. 2.47. Now let me read out the problem. Two loads of equal magnitude P. Here is a load, means its weight is acting vertically downward, its weight is acting downward due to the Earth's gravitational pull, are supported by a flexible string ACDB. This whole thing is a flexible string. This whole length, as shown in this figure is E, as given in the book Engineering Mechanics by Timoshenko. Determine the tensile force S1 and S2 in the portions AC and CD. AC will have a tension force, CD will also have a tension force, DB will also have a force of tension along the string. Of the string, if the length L, that is ACDB, this whole length, is equal to 9.144 meter, and the sag H is equal to 1.524 meter. Neglect the weight of the string. When these two weights are hanging, the string is pulled down, and this portion from this horizontal position, the amount by which it has come down is from here to here, that is H, and H is given as 1.524 meter. So let us discuss the solution. Length is given as 9.144, H is given as 1.524 meter. We have to find out the tension forces S1 and S2. If you look at the diagram, let S1 is the tension in the part AC of the string ACDB, and it will be away. For the point C, it will be to this side. Let it be S1. And for if you consider point A, it will be to this side. Similarly, in the part CD, let S2 is the force of tension. S2, right? For the point C, it is away from the point C. For the point D, it is away from the point D. And there will be some tension in the part DB also. Let it be S3, right? Which we are not required to find, but you can find if you still like. Now, I have redrawn the diagram for you. Here, this whole length is from here to here, L by 3, L by 3, L by 3. Now, so I have redrawn the diagram. Let angle CA, let this point is alpha. And because of the symmetry, right, angle DBF, this point is F, will also be alpha. Let me slightly clarify these things to you. If this load P is not hanging from this point, it is hanging from this point, then this alpha will be more than this alpha. This angle will be more than this. If this is hanging from this point, then this angle will be less than this angle because of the symmetry. Means this distance is equal to this distance is equal to this distance. These two angles alpha, these two angles will be equal. So from here to here is H. The value of H is given. Therefore, from E to C is also H. Now, if you apply tan alpha to this triangle, which is right angled here, tan of alpha is perpendicular over base, that is H over L by 3. So your tan alpha is H over L by 3. 3 comes to the numerator. This becomes 3H over L. and the value of L is given and the value of H is given. So just put it in a scientific calculator. So your alpha becomes tan inverse 3H over L. 3, this is your H over L. So this comes out to be exactly 26.572572 degrees. If you convert it to minutes and seconds of arc, this comes out to be 26 degree, 34 minute, 21.26 seconds of arc. What do you mean by minute of arc? Suppose this is 1 degree. If you divide this 1 degree into 60 equal parts, then one part, if you divide this into 60 equal parts, then one part will be called 1 minute of arc. And if you again take 1 minute of arc, 1 minute of arc, and divide this to 60 equal parts, then one part will be called 1 second of arc. And that is the meaning. Now let me draw the free body diagram at the point C. There are 3 concurrent forces, S2 to this side, S1 to this side, and from this point downward is the load P. So I have drawn the free body diagram at point C. Now look at, to this side is S2, that was horizontal, to this side is P, vertically downward, to this side is S1. Now the question is how this angle is alpha. So how this angle is alpha, if you extend this line like this, then this dotted line and this red line, they are parallel, and this part of the string AC is a transversal. So if this angle is alpha, this is also alpha because of alternate angles from plane geometry. So now the free body diagram, once the free body diagram is drawn, you can apply Lami's theorem also to solve, but we have to find out by method of projections in problem set 2.4. So I am using method of projections. So if you project this S1 to this side, from here to here, from this one, will be your S1 times sine alpha. If you project it on the x-axis, that is from this point to this point, will be the projection of S1 on x-axis. So this will be S1 times cos alpha. How this comes in cos function, how this comes in sine function, I have already explained in previous videos. This obviously does not have a component along y-axis. This obviously does not have a component along x-axis. So since it is an equilibrium, let us first begin with a sigma y is equal to 0. To this side is your S1 sine alpha, and to this side is P. This is opposite to P, and if they are equal, then they will cancel, and the condition of equilibrium will be established. So S1 sine alpha is P. So sine alpha is taken to the other side, P over sine alpha. Alpha was just calculated. I have put the value of alpha. So this can be written as P times 1 over this. So when you put these values in a scientific calculator and take the sine of it, and 1 over that comes out to be 2.2354 multiplied by P. So this is your S1 is your first answer. Then the second answer, to find S2, I have to, now how much is this? This is your S1 cos alpha. In this triangle, which is right angle at here, if you take cos alpha and cross multiply, you get this length. The projection of S1 on x-axis as S1 cos alpha. Now if you look at S1 cos alpha and S2, they are opposite to each other. So if the value of S1 cos alpha and S2 are equal, they will cancel. So the net force will be 0 along x-axis. So that is what I have explained here. Sigma x to be 0, because this is the condition. This is one condition for equilibrium. This is another condition for equilibrium when projections are considered. So your S1 cos alpha is equal to S2 So your S2 is equal to, this is your S1 which I just calculated, cos of alpha, put it in a scientific calculator. This comes out to be 1.999271 times P. That is nearly, if you round off, 2 times the load P. Again, thank you dear GATE aspirants and all my viewers from India and from Bangladesh, which I recently discovered. Some of them have subscribed from Bangladesh. Congratulations and all the best. Thank you.